Good morning. Today we will conduct acids and bases day 2. Let's go. Aim, how do we differentiate between acids and bases? Now here is the do now question. I provided you table L at the bottom. Question says, which is the base? Hit the pause button right now and complete the answer. Okay, we're back. So, if you look over here on table L, we said yesterday that compounds which contain metals in the front, such as sodium, potassium, calcium. Remember, guys, metals are on the left side of the staircase. Usually group 1 or 2 when we're talking about here. Okay, sodium, potassium, calcium, which are metals, combined with the OH, which is hydroxide, will produce the base. Now, if you look over here, remember we said yesterday the 3 letters CHO, CHO. We said when you see CHO is a non-electrolyte. Non-electrolytes are poor conductors of electricity in solution. CHO, CHO. CHOs are not bases. In this case, these are alcohols, okay? I see a metal with a non-metal. What type of bond is that? That's right, ionic. And ionic bonds form salts. So salts are not bases. A base, we said, was a metal with the OH. Well, how come MgOH2 is not on table L? Well, these are some common bases. They're not all going to be there. But what do they have in common? Well, this is a metal. It's a group 2 metal, right? If you remember back what we learned, group 2 had a name. That was called alkaline earth metal. So you have a metal with the OH that produces your base. Okay, let's move on. There's a little reaction showed here when you drop a penny, which is copper, into nitric acid. It produces a reaction which releases copper nitrate, produces copper nitrate, nitrous dioxide, and water. Okay. Funny Pepto-Bismol commercial. Okay, here we go. Arrhenius acids. Now we said Arrhenius acids give off hydrogen ions. So acids always give hydrogen ions. Now, if you combine hydrogen ion plus water, that gives me what's called hydronium ion. Again, guys, whenever you see a word you don't know, what table? That's right, table E. So here's table E. If you go to table E, H3O plus is there, hydronium ion. You don't need to memorize it. Okay, so we learned this partially yesterday. We said all acids release hydrogen ions. So again, how do we know substance is an acid? Well, you learn that whenever the first element is an H, except for water, the first element is H, that is an acid. So when this is put into water, it will dissociate or break up into hydrogen ions. There's a positive ion, chloride is -1 charge. Remember where we looked that up. Good. You look at the charges on the periodic table. Again, this is sulfuric acid. Again, who's in the front here? That's right, hydrogen. Means it's an acid. This time, how many atoms are here? Well, there are 2 of them. So that's going to be 2 H's here. H plus ions. Okay, and then you have the sulfate, SO4 -2 there. We said this guy was a special guy, right? Because usually the H is in the front. Not for Chico. Chico, the H is where? That's right. The H is in the back. That is the positive ion. So only one with the H is in the back, all right, guys? So that's it. So usually, again, when the H is in the front, except for water, it's an acid, except for Chico or CO2. Always refer to your tables. Good. Makes it easy. Next, Arrhenius base. So I use red for acid because, litmus paper, red's acid. We'll get into that later on. And base are blue. So Arrhenius base give off the OH negative, which is called hydroxide ions in solution. It's a metal with the OH, like we said before, right? So here's your metal, sodium, is a group 1 metal. What were group 1 metals called again? Yes, alkali metals with the OH. So if you put this in water, this breaks up to Na plus, OH negative. Next, calcium. Calcium is a group 2 metal. Well, we said it before, right? A group 2 metal has 2 words. That's called alkaline earth. We're just, spiraling back. Okay, so again, a metal with the OH. This time, how many hydroxide ions are here? Well, there's 2 of them. It says OH2. This is only 1 over here. Okay. Last compound says here is CH3OH. The CHO. C-H-O. Tells you not a base, no ions released, and no metals present, right? Carbon's not a metal. If you refer your periodic table, carbon's on the right side of the staircase. That is a non-metal. Okay, so again, acids release H plus ions or H3O plus. Acids have the H in the front, except for Chiku, the H in the back. Again, look at your table K there. Arrhenius base gives off OH negative ions, or what's called hydroxide ions, in solution. Metal with the OH. NaOH, Na plus, OH negative. A metal with the OH is a base. If you don't have a metal with the OH, it's not a base, except for NH3. Again, refer to your tables. Let's proceed. Bronzolaric acid. Okay. Now, it tells you over here, bronzolaric acids donate a proton. Okay, a proton's H plus, basically. Right, positive charged particle. To a base, has 1 more H plus. An acid on the left-hand side always has a conjugate base on the right. All right, let's make this easy now. This is what it's saying, basically. Let's look at this reaction over here. I see HCl plus water, double arrow, H3O plus, hydronium ion, plus chloride ion. Guys, all you have to do is this. Connect the substances that look similar. The only difference is there's going to be 1 hydrogen. One compound's going to have 1 more hydrogen, the other one's going to have 1 less. So HCl on the left looks like which guy on the right? Well, it looks like Cl negative. The only difference is HCl has 1 more hydrogen. This guy has 0 hydrogens. So that's what's called conjugate pair. The one that has 1 more hydrogen ion is your what? That is your acid. So that means that this is the acid, because this has 1 hydrogen. This guy has 0 hydrogens. That must be your base. Now, you can never have 2 acids or 2 bases on the same side. So if this is an acid, this must be a base. If this is a base, this must be a acid. Well, let's just prove it to you. So connect this pair, which looks similar. This is 2 H's, this is 3. Again, the one that has 1 more is your acid. The one that has 1 less is your base. Good, let's try this one over here. Actually, I'm going to have you pause the video and try this one yourself. Okay, we're back. NH3 connects to NH4 plus. Again, this says 4 H's. This says 3. The one that has 1 more ion, hydrogen ion, is your acid. This must be your correct base. Again, if this is a base, this must be an acid. If this is an acid, this must be a base. Sorry for the B, it looks terrible. Okay. Now, let's use a different color here. Let's go back up here. It says acids donate a proton. So very simple. On the same side, after you connect and determine which is the acid or the base, the acid always donates to the base. Acid donates, base accepts. Acid donates, base accepts. Go down here. Acid donates the proton, base accepts. Acid donates, base accepts. And just so you know, forward reaction means which way? Going to the right or to the left? Well, forward means going to the right. Reverse means going to the left. Okay, let's move on. Bronzolari base. Yes, unfortunately, this woman here was burned by putting too much lye on her head to straighten her hair. And then lye is an extremely powerful base that, if it's left on long enough, can cause severe burns. So be careful. Here we go. Okay. So we said before, a bronzolaric acid donates the proton. Hold on a second. A bronzolaric acid donates. So that means a bronzolaric base accepts a proton from an acid. A bronzolaric acid is one more H plus. A bronzolaric base is one less H plus. Again, I'd like you to connect the compounds that look similar. Water on the left will connect with H3O plus. H3PO4 will connect with H2PO4. Because this is two H's, this guy is three. They look similar, right? The one that has one more is your what? Acid. The one that has one less is your base. Now we say you can never have two acids, two bases the same size. So if this is a base, this must be an acid. If this is an acid, this must be a base. What did we say before? Acid donates, bases accept. Acid donates, base accepts. Acid donates, base accepts. Now hit pause and please answer the question below. Okay, let's go on. Here's our famous compound, CHOCO, acetic acid. CHOCO is going to connect with which guy on the right side? Well, CHOCO. The only difference is this has one H here. This does not have the H there. So we said the compound with the one more H is your acid. The one less of the pair is the base. If this is a base, this must be an acid. That's an acid, this must be a base. Because when you connect them, this has one more H, this is one less. What did we say before? Acid donates, base accepts. Acid donates, base accepts. Acid donates, base accepts. Any questions? If you do, always shoot me an email. And that's it.